Right. Hello, we're Team Retro Snakes. This is the AEP challenge.
So a key requirement that we had was to measure the power generated by a solar panel with reflected light. The design must be portable, communicate our data to us, and also be versatile for positioning and taking data. Our approach to solving the problem, we encountered limitation where we were unable to obtain an AEP kit. And to work around, one of our group members has a set of 3 solar panels. So testing, we first had to perform testing for each solar panel array.
So the end product is kind of a futuristic idea where the sun would hit your clothes and your clothes would be able to create this air conditioning effect. It can heat you up or cool you down. This is how we created the prototype.
So we took the 3 solar panels provided by one of our group members, and we mounted them together in parallel configuration, and that went the back, and then on the other side we had an Arduino Uno setup with an LCD screen that could measure the voltage and the power from the solar panels.
So here was an initial measurement just using a phone light, getting the voltage with no load. And the purpose of doing this was to try to characterize the solar panels. So solar panels have something called an IV curve. So as the output voltage increases, at some point, the current will drop. So this IV curve helps find the maximum power output of the panel. This is with a lamp.
Can the panels measure reflected light? Was the end question that we're trying to solve here. And yes, they can. And we used an op amp to help amplify the output due to low output in the initial.
Here's kind of the simulation that we ran.
Here's a schematic showing. Yep.
This is measuring the total current consumption of the whole system.
Here's an initial test showing reflected light from the carpet we measured.
And through that measurement, we were able to create 2 IV curves, one with sunlight, one with phone light.
So we went outside as well and tested the results on different surfaces such as granite, concrete, grass, asphalt, and a car hood. We were able to graph power versus voltage.
We found asphalt was the material that produced the most power.
Here's some code that we use to actually output the data onto the LCD screen. Some issues encountered along the way were soldering up, trying to configure the op amp, and some finicky potentiometer work.
That's all we had. Thank you for sponsoring the channel.